So, starting point of understanding artificial general intelligence is understanding generative AI, and starting point of understanding generative AI is to understand about machine learning models. So, when we say machine learning models, it involves four kind of learning. One is supervised learning, other one is unsupervised learning, third one is semi supervised learning model, and fourth one is reinforcement learning model. So, supervised learning model involves data sets where data has been already mapped between input and the known output. I mean, relationship between the input and output has been established already, and data has been already labeled, right? For example, when you say labeled, when you have a basket of mangoes which has both ripened and raw mangoes, by looking at the color and by knowing the weight of those mangoes, we can clearly tell whether the mangoes are ripened or raw ones, right? That kind of defining whether it's ripen or labeling them as ripen or raw is called labeling, right? So data is labeled, and data's features also be having distinct features like color of the mango, weight of the mango, size of the mango. All those are called features. So in the supervised learning, data will be having labels, input output output are difference between input and output are clearly established, they are mapped, and distinct features within the data is clearly called out, based upon which the machine learning model, I mean the supervised machine learning model, will make accurate predictions. In semi supervised learning model, part of data will be having labels, and large set of data won't be having labels, or time on cost of labeling the rest of the data is not doable or cannot be afforded, right? So based upon the labeled data, the learning of the A component agent will continue. And in unsupervised learning model, the algorithm is given a data set without explicit instructions on what to do. Meaning, unlike supervised learning, no input and output pairs are established, meaning no relationship between input and output are established. And in unsupervised learning, there is input data X but no corresponding Y output label. As I said, in the supervised learning model, if the Y can be categorized for classification or regression problem, if Y value is having floating points or numbers. Okay. Whereas in the unsupervised learning, objective here is to find hidden patterns, structures, and relationship within the data set itself. The output of unsupervised learning can be fed to supervised learning models to enhance the accuracy of the predictions or the outcomes by applying, of course, by applying relevant models and algorithms. So think of unsupervised learning just like rules of games. By watching a game, a baby or a toddler or a person who doesn't even know about a game, by gradually watching and understanding and by gradual perception, by gradually perceiving what to do and what not to do in the game, he can understand the game at a certain point in time, right? Think of the way babies learn without teaching, right? So if a baby by mistake touches a hot cup of tea for the first time, it may not know that it's going to hurt his or her fingers, right? Once it get that sensory perception of getting hurt by touching a hot object, next time automatically the baby as it approaches a hot cup of a glass of hot cup of tea, it will be very cautious, right? And it will also try to understand, will there are there any other objects that's hot in its environment can hurt its finger. So basically, once it gets that learning, it knows how it needs to behave or how it needs to be careful, despite its limited understanding of its environment. Whereas in supervised learning, it's all about predicting an answer, essentially a label which was already defined. And in unsupervised learning, the training data set is fed to the algorithm without labels being mentioned, or it can also be applied for the data sets where labels can't be recognized at all. So the idea essentially is to find the hidden patterns, structures, and relationship within the data, than labeling the data itself, right? And we have few algorithms that can function or can process the data that are lacking labels in it. And few such algorithms are clustering algorithms, algorithms that deploys association rule mining, and there are algorithms that can detect anomalies, and there are algorithms that can understand the data pattern and recommend the data pattern that we might be looking for. Those are called recommender systems. And we also have another algorithm that is called dimensionality reduction, where it the AI system can understand which variable really contributes to the outputs. And we also have some data generative algorithms that contributes that can be applied for unsupervised learning models. So let's talk about how autonomous cars like Tesla work, right? Because most of us somehow think Tesla uses unsupervised learning model. It while the kind of learning Tesla deploys is not fully knowable for the fact that all the proprietary, because these, the kind of learning model that Tesla uses, the kind of algorithm that Tesla uses, these are all proprietary information, which won't be available in the open internet. Yeah. So, but however, we can, by understanding the learning models, we can clearly guess what the kind of learning model that Tesla deploys, right? Because applying unsupervised learning model in autonomous car where safety is very fundamental is not possible, at least when it comes to steering, driving. Maybe the other features within Tesla, like understanding the internal temperature, the air conditioning temperature, or understanding about dynamics within the internal components that doesn't involve driving, maybe using unsupervised learning. But when it comes to autonomous driving, for example, the autopilot or full self-driving systems in the car, those systems are not doing unsupervised learning. Rather, they do supervised learning, meticulously planned supervised learning, covering all the aspects of safety. And equally, reinforcement learning model is also deployed in Tesla. So, as I said, the autopilot and full self-driving features uses combination of deep learning algorithms and AI models extensively in its autonomous systems. There is no reliable data on Tesla's usage as to how the systems learn, because the type of learning that Tesla uses, as I said, and the type of algorithm Tesla uses, these are all proprietary informations and won't be available in the open internet due to competitive reasons of Tesla. Right. So let's see how Tesla gets input, how it gathers input data for its autopilot and full self-driving mode models. So this autopilot or full self-driving mode processes vast amount of data generated through cameras, its radar, and from its ultrasonic sensors. And remember, to enable semi-autonomous driving capabilities and to recognize and interpret the surrounding environment, including other vehicles on the road, pedestrians on the road, and road markings, and how they process all of these real-time data collected through the computer system on board. The computer system on board plays a crucial role in Tesla's autonomous driving capabilities. It involves not advanced, modern neural networks called CNNs, otherwise called as convolutional neural networks, and other deep learning techniques to identify the objects like lanes, pedestrians, other cars, and traffic signs. And it besides convolutional neural networks, it's been widely predicted that they also use YOLO algorithm. And so Tesla applies these deep learning models, and that's how it augments steering, acceleration, and it's braking based on real-time environmental conditions. So this kind of machine learning called reinforcement learning algorithms are used to enhance Tesla's navigation systems, providing accurate routing based on historical data and real-time conditions.